Welcome back, everyone. So in this video, we're going to learn about confidence interval estimates for a population proportion, as well as how to calculate the required sample size. So recall the formula for a sample proportion is x divided by n. We also learned how to calculate the standard error for a sample proportion in chapter 7. That is this formula right here. Now in this chapter, we're going to be estimating the population parameter because we don't know what the population proportion is. Therefore, we'll use a sample proportion as the estimate for the standard error. So as you can see here, we're modifying the standard error formula to use the sample proportion, or P bar. So the general format for the confidence interval estimate is still the same structure as before, where we had a point estimate plus or minus the critical z-value times the standard error. So here is the formula where P bar for the sample proportion plus or minus the critical z-value times the standard error. Recall, we learned in chapter 7 that the distribution of the sample proportion is binomial. The central limit theorem tells us that we can use the normal distribution as an approximation. Once again, that is nice for us because then we only have to use the critical z-values when calculating our confidence interval estimates. So I provided the table with the commonly used z-values here, again, for quick reference. So let's go ahead and look at an example. Bed Bath & Beyond is interested in estimating the proportion of the population who received a coupon and used it. Say a random sample of 100 individuals has been selected to receive the coupon and 22 people redeemed it. Develop and interpret a 99% confidence interval estimate for the population proportion. We need to first determine the sample proportion of the people who use the coupon. So to do that, we will take x divided by n, or the 22 people who used the coupon divided by the 100 people in the sample, and we get 0.22 for the sample proportion, or P bar. So here is the formula again. The z-value is based on the 99% confidence level in our table. We can see that the z is going to be 2.575. The sample size is 100, and that was defined in the story. So we'll go ahead and plug in all of our numbers into the formula, and let's solve to the right of the plus and minus sign. We'll take z of 2.575 times the square root of 0.22 times 1 minus 0.22, or 0.78, then divided by the sample size of 100. And when you're doing this calculation, just watch out for your order of operations. And that gives us a margin of error of 0.1067. So to get the lower limit, we will subtract 0.1067 from 0.22. And then to get the upper limit, we'll add 0.1067. And that gets us a confidence interval estimate of 0.1133 to 0.3267. In other words, it means that it's estimated that 11.33% to 32.67% of people will use the coupon. That is a pretty wide interval, and as we learned before, to get a smaller interval, we would either need to reduce the confidence level or increase the sample size. Let's now do a practice problem 8.54 from the textbook. A random sample of 200 items reveals that 144 of the items have a particular attribute of interest. So in part A, what is the point estimate for the population proportion for all items with this attribute? So we'll go ahead and take the formula of x divided by n to get the sample proportion. So that is 144 divided by 200, and we get 0.75 for the sample proportion. In part B, you're asked to use a sample to develop a 95% confidence interval estimate for the population proportion P of all items with this attribute. In this example, since the problem is generic, you don't need to define the variable of interest since it just tells us the number of items meeting some attribute of interest. So in step 2, we'll just need to identify the sample size, which is 200. Now in part 3, we need to find the critical value. So the confidence level that you were asked for was 95%. We have seen this several times before, but now looking at the reference table, we know that the z is 1.96. In step 4, we'll just bring over our sample proportion from part A of 0.72. So we'll go ahead and plug in the different variables into the formula. Again, we're going to solve to the right of the plus and minus sign. Again, we will solve to the right of the plus and minus sign. we'll take the z-value of 1.96 times the square root of 0.72 times 1 minus 0.72 or 0.28 divided by the sample size of 200. That gives us a margin of error of 0.0622. So to get the lower limit, we'll subtract 0.0622 from 0.72. And then to get the upper limit, we will add 0.0622. And that gets us a confidence interval of 0.6578 to 0.7822. Okay, let's wrap this up and learn how to calculate the required sample size to estimate a population proportion. So in the top box, we have the margin of error formula again. And then here is the formula for calculating the required sample size when we are estimating a population proportion. Like the required sample size for a population mean, we have z squared in the numerator, and then the margin of error is squared in the denominator. The different piece now is in the numerator, we are working with proportions. So we'll multiply z squared times the population proportion times 1 minus the population proportion. Let's look at an example. A marketing research firm wishes to develop a 95% confidence interval estimate for the proportion of customers in a market area that will have a favorable response to a new advertisement. They want their estimate to have a margin of error of plus or minus 0.015. A pilot sample of n equals 40 people showed that 33 had a favorable response. How many additional people should be surveyed? So here we must find our sample proportion. We will then take the 33 people who liked our ad divided by the 40 people who were sampled. That gives us a sample proportion of 0.825. The z-value based on the 95% confidence interval is 1.96. The margin of error is 0.015, which was given in the story. So plugging in all our numbers into the formula, we'll take 1.96 squared times 0.825 times 1 minus 0.825, then divided by 0.015 squared, and we get 2,464.03. Recall from the last video, we always want to round up our sample size regardless of how low the decimal point is. So we get a sample size of 2,466. So the net required sample size would then be 2,466 minus the pilot sample size of 40 to get 2,426 additional people that we need to survey. Let's go ahead and do practice problem 8.52 from the textbook. Time Magazine Company is planning to survey customers to determine the proportion who will renew their subscription for the coming year. The magazine wants to estimate the population proportion with 95% confidence with a margin of error equal to plus or minus 0.02. What is the sample size required? Now let's make sure we understand our variable of interest. In this case, we want to know who's going to renew their subscription. So the current magazine subscribers is the variable of interest. So in step 2, we'll define the confidence level and z-value based on the story. We have 95% confidence level again, and we know from prior problems and the reference table, z is 1.96. So hopefully you will have the z for 95% confidence level memorized by now. Then in step 3, we want to make sure we identify the margin of error in the story. We were told that they wanted a 0.02 margin of error. Now in step 4, if a pilot sample exists, then you compute the sample proportion and use it to approximate the population proportion. If no pilot sample exists and we cannot reasonably estimate the population proportion, we use 0.50 as a conservative estimate. So in this problem, no pilot sample exists, so we'll use 0.50. So plugging in all our numbers into the formula, we will take 1.96 squared times 0.50 times 1 minus 0.50, which is also 0.50, then divide by 0.02 squared, and we get a sample size of 2,401. In this example, the calculation landed on exactly 2,401, so no rounding is needed. So to wrap up this video, as well as the prior video on required sample sizes, what exactly affects our sample size requirements? First, the desired level of confidence, and a higher confidence requires a larger sample. Then, the desired margin of error, and a lower margin of error requires a larger sample. Then finally, the population variation, and greater variation requires a larger sample. Well, everyone, that wraps up this video on estimating a population proportion. That also wraps up Chapter 8.